at 100 rupees per kg, and if he sells that mixture at 120 rupees, you can get 20% profit. Okay, by the same way, this is model number 8, model number 7. Okay, by the same way, you can identify the some more problems in the profit and loss by using that format. Okay, look at here, simple way. Coffee merchant has two types of coffee powders, 80 rupees per kg, 120 rupees per kg. If the mixture of C1 and C2 was sold at 120 rupees per kg, there arises 20% of profit. In what ratio should he mixes C1 and C2? Okay, so here C1 and C2 mixing ratio, to find that one, you should have to first of all identify that cost price of that selling price content. So cost price here is, your cost price is always 100%, sell profit percentage is 20% what he has given. So selling price is 120%. So 120% value is 120 rupees per kg, 100% value is 100 rupees per kg. So that's why you can identify the 100 kgs. Here the price should be at cost price. This is the major point here. Sometimes I gave you loss also. Sometimes I gave you the loss also. Okay, if the selling price is 80 and the loss percentage is 20. Okay, a coffee merchant has two types of coffee powders, C1 and C2. Okay, and here it is 80 rupees per kg and it is also 120 rupees per kg. Okay, if he sells the mixture of C1 and C2 at 80 rupees per kg, he attains a loss of 20%. Okay, then cost price is equal to question mark. In this case, we should have to analyze a simple way. Cost price is always 100%, then loss percentage is 20%, then cost here selling price percentage is 80%. Okay, because it's a loss. This 80% is equal to selling price, that is 80 rupees per kg. Okay, then 100% value is 100 rupees per kg. Then 100, then the same answer is arises 1:1. This is model number 7 and model number 8. Okay, so this model is very important to you. Here the format here for profit and loss is cost price is always 100%, profit and loss are based upon the cost price is P% or L%, and selling price is 100 plus P% or 100 minus L%. Right. And the last model here is reduction model. Okay, reduction or reducing model. Suppose for example, initially a vessel contains 200 liters of pure milk. Initially a vessel contains 200 liters of pure milk at starting. Okay, if every time 20 liters of pure milk, is removed and replaced with water, every time 20 liters of pure milk was removed and replaced with water. Okay, if it is done for 2 times, then what is the milk content in that mixture? If it is done for 3 times, what is the milk content in that mixture? Okay, by this way. Okay, before doing this one, you should have to identify the one thing. Initially 200 liters, in that 20 liters is, that means here, look at here, initially 200 liters is equal to 100%. Okay, then 20 liters is equal to how much of percent? 20 by 200, that is 10%. Okay, if 100% value is 200, then 20 liters value is 10%. Every time 10% of pure milk is removed and replaced with water. So if it is done for 2 times, initially in 200, first 10% was removed. Okay, so if 10% was removed, what is the resultant content? It is 100%. If 10% removed, okay, what is the milk content here? Here it is 90% and here it is 10%. That means here in that 180. Okay, so again 10% is removed. That means 9% is removed. Okay, in 90, okay, take it as 100. Again 9%, 10% is removed. Again 10% is removed. So 10 by 100, that is 10% is removed, 18 liters is removed. Every time it is reduced by 10%. That means if initially 100%, if 10% removed, it is 90. Again if 10% removed, it is 81. Again if 10% removed, it will be 81 minus 8, you can get 73. 73 minus 0.1, you can get 72.9. Okay, for 100 it is 72.9. For 200 it is 144.1. Okay, 72.9 plus 72.9, you can get 145.8. You can get the answer directly by this way. Okay, look at here again. Every time in that 100, 10% removed and 90 is existed. In that 90, again 10% is removed. 81 is existed. Again 10% removed. That means 8.1 is removed. You can get 72.9. For 100, it is required after 3 times. For 100, it is 72.9. For 200, it is 145.8. Okay, this is a reduction model. Sometimes you may use the formula future value is equal to present value into 1 minus I1, 1 minus I2, 1 minus I3, like this. So here future value is unknown thing, present value is 200 liters and 1 minus I value is 10. So here 90 by 100. If 10% was removed, again it is taken as 100 and 90 is existed. And again it is taken as 100 and again 90 by 100. When you apply this one, 0 0 cancel, 0 0 cancel, 0 0 cancel, 1 2 1 2 cancel, 9 9s 81, 81 9s, 9 8s 72 and 9 9s 9 1s 9. So 729 into 2, you can get 145.8 as the answer by using the formula and without using the formula. It is the best way. Okay, I am repeating this process again. You may conclude the answer. First of all, you should have to find out the reduced and replaced percentage as based upon the initial one. Initial must be taken as 100%. Reduced content should be identified as in percentages. Then future value is equal to present value into 1 minus I1, 1 minus I2, 1 minus I3, like this. If 3 times it was done, future value is equal to 200 liters. In that 200 liters, 10% removed. Okay, so what about the remaining 90? Then what about the 90 value? Okay, again this is taken as 100% and in that 10% is removed. That means 90 is existed, 90 by 100. Again this must be considered as 100%. Again if 10% is removed, what is the 90% value? That is the final value. By using this formula, I value must be taken as 10 by 100. So 10 by 100, 90 by 100, 90 by 100, 90 by 100. By using the format or without using the format. Here 0, 0, 0, 0, 0, 0 cancel. 1, 2 zeros, zeros cancel. So you can get 9 9s 81, 81 9s 729, 729 2s. Okay, here 729, 729, you can get 18, 5, 14. So 1458 by 10. 1458 by 10, you can get the answer as 145.8. This is one of the way. But another way, initially if taken as 100 liters approximately, if 10% is removed, it is 90. Again if 10% is removed, again it is 81. Again if 10% is removed, that means 8.1 is reduced, you can get 72.9. Okay. For 100 it is 72.9 is the final value. For 200 it is 145.8. Okay, these are the models in alligation and mixture. Okay, so this concept is very important for solving the average identification of the two different variable items. Okay, thank you very much and thank you for watching this video.